Okay, so let's do some more practice with orbital hybridization. So what we're doing is we're going to go back to this VESPER practice where we looked at these six structures for molecular geometry, and we're going to assign orbital hybridization to each and tell how many sigma and pi bonds there are for each. Okay, so let's start here with our carbon tetrachloride, and this was an example that we had already used. So now let's say, what is the orbital hybridization? So I'm going to say the orbital hybridization here, because I have a steric number of 4, and I need 4 equal orbitals for these electrons to share. It's going to be sp3 hybridized. And this molecule here has 4 sigma bonds. Okay, let's look here. Here I have 4 regions of electrons around this NH4. So that means my orbital hybridization, again, is going to be sp3. And here I have 3 sigma bonds, 3 single bonds. Okay, so let's go over here to the carbon dioxide. The orbital hybridization, I have 2 regions of electrons, so this is going to be sp hybridized. I have 2 sigma bonds, and I have 2 pi bonds. Remember, the first bond in each bond is the sigma. If there's a second or third, each of those would be a pi bond. So I have 2 sigma and 2 pi for the overlapping orbitals. Here, I can't really do orbital hybridization without a central atom, so I'm going to skip this. This was just an example. I wanted to show you 2 atoms, it being nonpolar. Okay, here, again, orbital hybridization. If I have 3 regions of electrons around a central atom, it's going to be sp3 hybridized. And again, with 3 single bonds, it is going to be 3 sigma bonds. Here I have 1, 2, 3 regions of electrons around the central atom. Don't forget these electrons that are in the Lewis structure that are not in the molecular geometry. So this would be 3 regions, so it's going to be sp2 hybridized. I am going to have 2 sigma bonds, 1, 2, and 1 pi bond. So now we've been adding throughout the chapter for all the pieces of information that we're able to do for each molecule. You should be able to, from the name, write the formula. From the formula, write the correct Lewis structure. From the Lewis structure, determine the steric number, the electron geometry, the molecular geometry. From that molecular geometry, you should be able to assign vectors and tell me if the molecule is polar or nonpolar. Based on the steric number, you should be able to tell me the orbital hybridization, and you should be able to differentiate between sigma bonds, which is the first single bond, and pi bonds, which would be a second or third bond over that single bond.